3, 2, 1, ignition.
If I'd known this rocket would end up my craziest engineering challenge yet, I probably wouldn't have named it after a pasta. But alas, meet spaghetti carbonara, my first fully 3D printed carbon fiber rocket, all in pursuit of breaking the toughest 3D printed ceiling yet, the sound barrier. This rocket is either going to be the fastest 3D print on record, or the most expensive method yet of making 3D printer spaghetti. But I couldn't have done it without this video's sponsor, Bamboo Lab, and their crazy powerful new H2S printer. So I ordered the coolest filament I could find. This is PPACF. It's $150 a roll. Low-key, I am very nervous to open this box. $150 is a lot of dollars. But the specs that it touts are impressive. It is stiffer, stronger, and has a higher heat deflection temperature than any filament I've ever seen. And the fact that I can print carbon fiber at home in my home 3D printer is crazy. I'm a very impatient person. I've heard it go either way on, you're definitely supposed to dry out the material before you get it, but I just took it out of a vacuum bag with a desiccant packet in it, so maybe it's fine. But if it's not fine, I don't have a drying oven, but I do have a 3D printer, and you can use that. It just takes a little longer. So, what is this? Look at that CAD model. Ooh, it's so good. Anyway, I already did that. But I suppose we can hop in a time machine real quick and I'll show you how and why I designed this beauteous rocket. Now, I'm not gonna give you a full CAD tutorial, but I will highlight some of the key features of this rocket that make it so exciting. And I think the biggest one is that because it is fully 3D printed and not being fabricated out of carbon fiber the way I would traditionally do it, I could give each fin a real airfoil, and that'll make it just go a little bit faster and hopefully a little bit straighter, because I know that they're all gonna be perfect. But yeah, then I modeled the rest. I modeled a little mount for a camera. I'm gonna fly an Insta360 Go 3, which is the tiniest camera that I have, and then a nose cone that has an avionics bay. And again, man, it's so easy to be able to just model stuff and then click print and it appears in the real world. God, it's so exciting. Dude, the Bamboo printers are crazy. I just loaded PPACF into the printer, and now all I have to do is hit synchronize now, and wham, PPACF shows up as one of the available filaments. And so I just say change filament, and I say PPACF. And I can take a look at my model. I can say, this looks pretty good. This looks like a rocket, which is the goal. All right, print plate. It even auto time lapses, so I don't have to set this big camera up and risk it overheating like it has a tendency to do. I just say time lapse and wham bam, done, time lapse. Oh, did you just hear it start? Oh no, we're going on a little tour of my house. Going on a little tour of my house. You're seeing how the sausage is made. Okay, I'm gonna say something because all you 3D printer nerds are gonna notice that this is footage of me loading PA6CF, not PPACF, which is what I'm actually using for this print because the footage just came out way better. But also now I'm kind of just killing time because there's not that much to talk about with loading this printer. It's just so easy. You literally just select your filament and then push it into the tube, follow the instructions, and you're ready to print. You can see me in the reflection of the video, nervously standing around. Not a big 3D print watcher, but I gotta make sure it feels loved. Aww. Okay, so we are 45% of the way through this print. I feel like I'm jinxed to knock on wood, but it hasn't failed yet, which is impressive considering how tall of a print this is and that I loaded this carbon fiber filament into the printer without any kind of test print. Also, can we give a shout out to how good the time lapse looks where the head's in the same spot? Ugh, so good. Okay, so I noticed a little layer shifting here, which honestly isn't that surprising given that I've created pretty much a 3D printer torture test. There's an hour 30 left in the print. I'm trying to figure out if I leave it and see how it does for the rest of the print or if I kill it now, because I have an idea. Let me show you. So I've been avoiding chopping this up because the rail buttons need to be aligned. And so the easiest thing to do is to just print it all on one plate because then the rail buttons will be aligned. However, I drew this little sketch. If I split the body on that sketch, they'll line up and the notches will slide into each other, and mayhaps I can print the body in 3 pieces and these rail bends will stay aligned. So that's my new plan. Now it's worth noting that you can't print carbon fiber filament with the same settings as PLA. Bamboo has a bunch of really good resources on their website. There's also two YouTubers I referenced a lot, Superfast Matt and Clow42, that have great videos on this stuff, but also it was pretty plug and play. 7 hours. It's a solid overnight print. This is a terrible idea. This video, I am not setting a very good example of good 3D printing hygiene. I'm sort of just throwing everything on the build plate and seeing what happens. It's a top of the line printer. I may as well push it to the limits and also maximize my sleep. So that's the plan. Now, something that makes these Bamboo H2S and the H2D printers so effective is that for high temperature printing, which you need for advanced materials like carbon fiber or glass filled filaments, is that the chamber is sealed. And so the internal air is actually recirculating through an air filter and the heater to stabilize the heat inside the bed. And that's how you get these consistent prints. Good morning. It looks like the print didn't fail. The reason I'm okay with these separations on the motor tube is that the motor is actually longer and will cover both of these. So the motor itself is gonna like really hold these pieces in place. Exciting! So now I can send the next job to the printer. Now, one of the lessons I did have to learn the hard way with this expensive filament is that the fuzzies that you're seeing on the seam lines of the print are because I didn't sufficiently dry out the filament. So that is like the biggest side effect of having insufficiently dried filament. And later on, I started drying out the filament and that all went away. And it finished. Ow. I forgot how much hotter the printer has to be for carbon fiber filament. Surface finish looks really good, but because I didn't dry the filament, the seams are visible. And then the fins feel really good. The reason I wanted to use this carbon fiber filament so bad is I don't want the fins to flutter at all. And fins like to flutter at supersonic speeds. I need to put the threaded inserts into the sled for the telemetrum. So I'm gonna turn the soldering iron on and also my little fan for safety, because I opted for PLA for the flight computer sled just because a flight computer on carbon freaked me out a little bit. Dude, I'm so bad at this. It would be so cool if I could just be like functional at anything. I need to take this over to Joe's house and borrow his ground station because I don't have a ground station, so that I can test whether or not the telemetrum can talk to the ground station from inside of the carbon fiber nose cone. Because traditionally carbon fiber makes a Faraday cage, but it's a lattice structure, and with 3D printing it's kind of not a lattice structure, it's just like, what is that, unidirectional. I basically just need to take this, attached to this, and stuck up that screws in, and then that goes on top of that, and that's how big this rocket's gonna be. Very small baby. All right, so I got my telemetrum inside the carbon fiber nose cone, beeping away happily. We got the fire burning for ambiance to give the telemetrum some encouragement. And here we have GPS's in view. I like how you reached from that side to cover the GPS coordinates instead of from...
It's just what I do. I just do this.
What do we think? We think yeah?
Yeah, no, this is plenty of satellites. You're having better luck with GPS than I do.
This is the Insta360 Go 3. It is the camera module that I'm using, and the reason I'm using it is because it is tiny, and it still shoots 4K 30. The biggest downside of building a rocket this tiny is that it's really hard to put a camera in there, and a down-looking shot is generally the best shot, but I couldn't afford the drag hit of having the camera module stick out of the rocket at all. So this section of the rocket where the camera goes in there, this goes in here, and 2 bolts go through, keep those together. This is Kevlar line. It's rated to 500 pounds, but hopefully I don't need all of that. All right, so I started by tying a figure 8 knot around this loop, and really this knot is what should catch the rocket. The rest of it is just safety line. So that goes in there, the washer on there, So it's this bolt in there that I don't really trust because I wasn't able to get like a good wrench on it. And also it's a good idea to just epoxy your eye bolts anyway. So I'm just gonna pour a little bit of epoxy in there, and this is Total Boat High Performance Fast. So this should take about 30 minutes to cure. All right, with this cured, I can now thread my safety line up through the nose cone. So there's some slack there. This line should really never get pulled, but if it does, it'll hold the telemetrum to the rest of the rocket. Slide our little camera in place. Stick this through. And now I have to put these two M3 screws in. And now I just need to take this line and push it up through. So again, the nose cone is not supposed to deploy, but if it does come apart for whatever reason, it'll just sort of dangle here. And there's my top section. My top payload. Okay, so I moved out here just so that I can like lay out my rocket a little bit better. So I have my nose cone assembly here. These will get glued onto the motor like this, and then this one goes on top of that. And the key is inside of this one is a little knob with a hole in it, and that's for the parachute line to attach to. So I never want these two to be the same length, so I'll put that one about here. And now I'm just gonna run this like 10-ish feet. That's pretty good. The airplane fuselage is about 14 feet, so I'm gonna use that as a loose measuring stick. If you don't have an airplane in your garage, you can use a ruler. So I'm gonna use a little parachute swivel. So through both of there. That's attached there. Poke that through, heck yeah. Whoop, and then just drop it. All right, so tied that line on with figure 8 knot. My rocket parts hate to see me coming. So really only need to protect the bottom. It's kind of weird seeing it all stacked like this because this is by far the tiniest rocket I've ever made. And it's still gonna go like Mach 1.5 and pull 34 Gs off the pad. Important though, is this rocket does not yet have a name. And I have done the things that I do when I cannot figure out what to name a rocket, which is hit up my Patreon Discord. Shouts out patreon.com/Xyla Foxlin if you want to be part of the community. It's really awesome. We're chatting on there all the time. And I've hit up Instagram, so go follow me at Xyla Foxlin on Instagram if you want to be a part of those polls to collect ideas. And some of the winners that I really liked, a couple of people suggested carbonara. And I actually think that's really funny because it's 3D printed and like spaghetti is a 3D printing failure mode. I do think spaghetti carbonara is like a very funny name for a rocket. So I guess I should start thinking about a decal. Okay, there's one more feature of the H2S that makes it so awesome for making rockets. And actually I am beyond tickled that like every single part of this rocket, except for the flight computer, was made on this machine because this can also cut vinyl. And so I designed a little decal that's spaghetti carbonara, and now I'm gonna figure out how to use the cutting module and cut it. I made my file here in Illustrator. This is my design. I think it's real cute. Spaghetti carbonara. It's like a little spaghetti font. And this is Bamboo Sweet. I've never used it before, but I guess I just hit make. I will admit that I bought this vinyl is not the bamboo vinyl, so it might not be dialed in quite right. But it's because I wanted to go to a craft store and observe the flavors of marinara sauce, which I realize is not carbonara, but fascinating. That was so fast. Man, that's so cool. This is awesome. And that is the end of my work day. I know this is an ad for the 3D printer, and it 3D printed a carbon supersonic rocket, but the fact that I can do this is just, I'm just tickled. I'm chuffed, if you will. I've decided to just quit faffing about and assemble. Wow, faffing about sounds a lot better when my British manager says it. I don't know if I can pull it off in the like crappy LA girl accent. Okay, I've decided to stop putzing around, fiddling about, wasting time, and just assemble this rocket before I head to FAR. So how this is gonna happen is these 3 tubes all get glued to the motor. First things first, this is a DMS motor. That means it's a single-use motor. It also has a built-in 14-second delay and black powder ejection charge, both of which I will be using. Start by putting the washer in, pour this little black powder charge in there, seal it up, and I will be using Total Bond in medium. It might be a little too runny. I might switch to thick, but I was worried with thick that it might be too thick, so. All right. Oh, shit. Oh, fuck. That was not the smartest thing I've ever done. I think my only choice here is to try to cut it off or break it off. Oh. Okay. Well, won't be doing that again. But luckily, it's a 3D printed rocket, which means that I have the CAD files already, and all I have to do is hit print overnight on my Bamboo H2S, and in the morning I'll have another perfect part. Good morning! It's the next day. I wore the same outfit in an effort to pretend that yesterday never happened, but given that I walked back into this nonsense, it's pretty safe to say that yesterday did happen, and that I am as stupid as I look. But anyway, first of all, look at the surface finish of this print. It's so good. I have discovered that drying the PPACF is a must. It makes a really, really big difference. But it's the difference between getting kind of a fuzzy print and getting a really nice finish like this. But I did run out of filament, and so there's like a very slight line here where I had to change the filament. I think it's pretty well bonded, so I'm not too worried about it. Take 2 on rocket assembly here. I'm gonna be a little smarter this time and mix up some epoxy. Epoxy, I know when it's gonna kick, and I'm not gonna accidentally kick it by twisting the thing too fast and heating up and whatnot. All right. Got that one in place, relatively drama-free. And now this one, it's important to make sure that those are on the same side. It is now glued together. I wouldn't say fully integrated rocket because I kind of just stuffed the parachute in there. Because I'm flying a Jolly Logic, I'm probably gonna pack the parachute on site so that I can program the Jolly Logic at the altitude that the launch site is actually at, which is like several thousand feet higher than my house. But what I can do, the most important task, big moment for this rocket, it's getting christened Spaghetti Carbonara. Welcome to the world, Spaghetti Carbonara. Typically you'd want to wrap the parachute in your Nomex, but this rocket is such a tiny minimum diameter that I can only wrap the lines and then the parachute will just sit on top and hopefully get protected by just it being like stuffed in there. Ready?
Pretty secure with my one hand. Yeah.
Telemetrum is turning on.
We're locked.
We're locked?
We're
How
locked.
many satellites?
11.
What?
Yeah.
This is unheard of. What do you think it's gonna do?
Oh gosh, go up,
Oh.
and then go down,
What speed?
but crack in 2.
Actually, it's supposed to crack in 2.
Okay, and then I think it's gonna crack in 3.
Zoe, what do you think is gonna happen?
I think that the GPS isn't gonna work.
That's the worst case scenario. I don't want that. What's your prediction?
I think it goes up. I think it deploys its chutes. I think it's going to split on a layer line when it deploys its chutes.
So split in 3?
Yeah, pretty much.
Wow! What do you think is gonna happen?
I think it's going to turn back into spaghetti.
Oh, you were waiting for that. You were waiting for that. All right. What's your prediction?
Prediction, dog leg left tumble. I mean, super fast.
He hates me. Did you notice? Not a single one of my friends said that they think this rocket's gonna work. Maybe I'm gonna say that. Nah, I think it's gonna shred on motor deployment or on parachute deployment. Nobody predicted that it would shred on the way up, but I do think that that is a risk. It's not as big of a risk as shredding on parachute deployment, but this is a commercial motor. Here at FAR, a commercial motor typically does not mean a bunker call, and I have specifically requested a bunker call because a supersonic 3D printed rocket is not the greatest idea in the world, potentially. I think it'll be fine, but I would rather have everyone here in bunkers, so we're gonna do that. Good luck, spaghetti carbonara. All right, bunkers.
Okay, good morning everyone. We're going to start with the launch of a minimum diameter small rocket, hard to see, black rocket on the second row. They go to about 10,000 feet. Everyone should be under cover at this time. Everyone needs to be in a bunker. We are launching in 5, 4, 3, 2, 1. Ignition.
Oh.
380 meters. Negative 72 meters a second. I would get in the bunker.
I still see it.
We're still getting packets. Negative 21 meters a second. Negative 20 meters.
I lost it after the event.
Negative 19 meters per second. Data age 16 seconds. Ground distance 1 meter.
You're not getting any new data.
Not getting data. That flight was not good. Last known packet was only a couple hundred feet off the ground, so. I swear, my rockets usually work. Yeah, the GPS coordinates never change.
If you look at the site map, no, sometimes you can see the path.
Unfortunately, in true telemetrum fashion, I got no GPS data, even though I was getting packets from the flight computer, which means that we're gonna just start walking in the direction that we saw an event, and with 5 of us looking, maybe one of us will find it.
The parachute is red, though I do not believe we will be seeing that. And the rocket is black, which is the worst color to find in the desert. So you're welcome, everybody.
In a flash of optimism that I was feeling not so optimistic, but Chatham's insisted was a good idea, we did bring the Aggie and, every several hundred feet check again for a telemetrum signal. But alas, it did not come to fruition.
Here's the thing is that inevitably out here you will break something and lose it in the desert and litter. And so you have to just pick up other people's as you see them to keep your karmic balance in order. I will say, the defeat is starting to settle in. I think I might have to call it as the first rocket I have lost to the desert.
Did you find the rocket?
No, but damn, we gave it a good try. And we definitely took more out of the desert than we accidentally put into the desert, so it's a bummer because now I won't know what happened to it. But it's out there, and maybe someone else looking for their rocket is gonna find it. So if someone finds spaghetti carbonara, let me know.
We're back home. Honestly, it didn't really hit me until I went to unload the car, and I was missing the rocket part of the unloading. I can't say I'm that surprised. I feel like none of us said in our predictions that the rocket would work, but secretly everyone's hoping that the rocket works. I think what sucks the most is not having answers and not having the flight data or the onboard footage. I just want to know. I'm okay with failure. Failure is an inevitable part of the engineering process, and I want that flight computer. But it's somewhere in the Mojave Desert.
It's a tough day when you lose a rocket.
It's a tough day. But everyone, look, that was my first donation to the Mojave Desert ever. And I've been launching out of FAR for 4 years. It was an inevitability. And also I think that is like the first rocket that I've had fail. And it actually feels really good to just like, that's on my record now, so it doesn't matter. Like I can do harder things and try harder things because I don't feel, I mean, I still feel the pressure to be perfect, but like not as much. Which is pretty cool. Sick. Anyway, now I'm gonna go take a shower and then take a nap.
I think he's gonna crack in 3. I think that the GPS isn't gonna work.
I think it's gonna split on a layer line when it deploys its chutes.
I think it's gonna turn back into spaghetti.
Dogleg left tumble.
I think it's gonna shred on parachute deployment. Psych! Y'all didn't think I was gonna give up that easily. I am back in the desert with a new rocket. Its name is Mac and Cheese, and this time I'm gonna break the sound barrier and I'm gonna be successful. Okay, so my hypothesis is that spaghetti carbonara failed on the z-axis, meaning that it split apart at the layer lines. And this isn't that surprising because the biggest weakness of 3D printing is that axis. And what makes carbon fiber like my Spite rocket so strong is that it's a bi-directional weave, so it's woven together like that, and it's held together with epoxy. But what I'm gonna do for Mac and Cheese is give it a flood coat of epoxy in hopes that just like glues those layer lines together a little bit more and gives it strength in that axis, because I'm really not that worried about the XY axis. I think that like the fins are very, very strong. Like they really don't flutter. It's the layer lines that has been worrying me. So. So it's launch day, except that we left the house at 5:30 in the morning and did not check if the launch was still on, and it's canceled because the road is washed out. So super bummed because I worked pretty hard to pull this rocket together in like 3 days. The worst part is I really thought this one was gonna work. I learned a lot of hard lessons from spaghetti carbonara. I made this one a lot shorter, which would put a lot less like moment arm and force on the layer lines. And I'm also pissed that like just drove 2.5 hours out here without checking if the launch was still on. Checked earlier this week, but I did not check yesterday or today. And the road washed out. It's nobody's fault. I guess it's my fault for not checking. Ugh. After my failure trying to launch from Lucerne, I hatched a plan to launch out of FAR the following weekend, only for the FAR road to also wash out. So I'm here at Jean Dry Lake Bed, just outside of Las Vegas, Nevada. This is my second weekend in a row trying to launch Mac and Cheese because everything in California is flooding and all the launch sites got washed out. So I flew out here to Vegas and we're gonna get this rocket off the pad no matter what. But it's actually been really fun. I've only ever launched from FAR or Rock, like my 2 local launch sites. And it's really cool to be in like a new place with a new community and meet all of the like cool rocketeers out here. So thank you, Tripoli Las Vegas, for your hospitality and kindness. This has been really fun. Get my flight computers all set up. I don't have long enough nails for this. Let that find some satellites. I've got 3 strong, 8 weak. All my batteries are above 90%. Everything looks good. She's little. Man, good luck, Mac and Cheese.
5, 4, 3, 2, 1, launching. Yeah, I can't see it. Oh, wow.
I really can't see it.
Wow. That was only an H219, guys. It was on a light little rocket.
Does anyone have eyes? Oh yeah, I see an event. Way up there.
What was the altitude?
Should be about 4,500 feet.
It went off the rock so fast.
So fast. It was. Joey B, it took you 8 years to land a rocket right side up, and Mac and Cheese just did it. Wow, fully intact. I am impressed. I cannot wait to get the data off of this. Max altitude of 5,756 feet. Max velocity was 340 feet per second. How do I change that to meters per second? What country do we think we're in? Okay, so the data is still downloading, so I don't yet know if it broke Mach, but I really hope so. So I'm showing an apogee of 5,756 feet, but a max velocity of 344 feet per second, which is only like a third of Mach, which really does not sound right. I forgot to drill a hole in the nose cone. I meant to. It was on my list of things to do. Yeah. Shoot. Oh my God. I feel so stupid.
Well, lesson learned.
Well, may as well head back. All right, so we don't need to look too closely at this abomination, but I was able to beg an H550 off of someone else here at the launch site in exchange for a donation to Tripoli, Las Vegas. Truly, Rocketeers are always like the most generous, caring, helpful people. I did plug this into OpenRocket. It takes 0.2 seconds to have a stability caliber above 1, which is the safety margin that I prefer. It's only gonna be 0.6 off the rail, so I'm a little nervous, but we're at the furthest rail. I think we're operating safely. It's just not necessarily the most successful rocket outcome, but this time I drilled vent holes, so. Continuity is good. Still getting data, so that's good. My tracker battery's at 75%, ground station battery's at 85%, low res 93, so I feel good. I think as long as if it stays straight for the first quarter of a second, then we should be good. Although this is gonna go significantly faster than the first. The first one simmed to Mach 1.1. This one sims to Mach 1.5.
Range is clear. Sky is clear. Going in 5, 4, 3, 2, 1, 0.
Holy shit!
Sweet. It's stable. It's gone.
230 feet per second, 47 feet per second, negative 15. Wow, that was
Faster I've ever seen.
That was very fast. That was kind of sporty. Negative 70 feet per second. Oh, that's not good. Negative 80 feet per second.
Okay, well, here's the deal. It's separated, but you don't have a chute.
Right. 3,500. Negative 70 feet per second. 3,000 feet, 2,900.
It's coming down. It's going to land a little hard, but...
Anyone else see anything? What do we think? Can a flight computer survive 70 feet per second?
Oh, easily.
Great. I don't need anything else. I just really tired of buying electronics. 1,500 feet, 15, 13, 12, 11.
Send me an email. Maybe I'll spot you.
10, 9, 800, 700, 500, 300. Should be
straight ahead.
Straight ahead. This is John. He's been helping me all day. Thank you, John.
No problem.
Oh, I might see it. That might be it out there. There's some black stuff.
1,200. I don't see a chute.
I don't see a chute either. Oh, it exploded.
It's still in it.
Oh yeah.
Look at this.
Wow. Do we think that the flight computer survived? Holy crap. Do you have a shovel?
Oh, I'm gonna have to get a shovel off now.
It's really came down fast. It'll be a testament to the strength of the 3D printed nose cone if it's fine in there.
It's not crushed.
Yeah.
So your electronics are fine.
I wonder if my phone's getting any data yet. Oh my god, it's data downloading.
That's a testament to the featherweight.
Yeah. Holy crap. Do you want me to do some digging? I'll trade you.
It's up to you.
I can do some digging. I did this. I caused this mess. Oh wow, it's dense.
It's
oh my
dense.
God.
It's tough. I don't know how it didn't implode.
I don't either. It's that carbon fiber. This is the first time I've had to
Me too.
dig a rocket. Really?
Yeah, me too. I've never seen it go that deep. Usually it explodes. It's wiggling a little bit.
Is it? Oh shit, I broke it. Okay.
We can screw off the top and try to get the rest
Oh
of the
yeah.
off.
Oh, there it is. Nice.
The antenna's stuck in there.
Oh,
So
look at that.
It'll slide right on there.
Yeah. That's crazy. Holy crap. All right. Max altitude 6,000 feet. Max velocity 1,669 feet per second, which is well over Mach. Well over Mach. We went supersonic with 3D printing! Yeah! Mach 1.48. Mach 1.48 3D printed! Yeah!
Also, I went home, downloaded all the data, and the first flight broke Mach.